Hello, AP Stats. Something I wanted to go over before I dive into the example problems we did not get to today in class. We were making on this example uh, regarding the Bedford Freeman and Worth Instagram account and the likes that the Instagram account gets. We made a box plot. Just to recap how to make the box plot, we find the median. We then find the median of the top half, which is called the third quartile. We find the median of the bottom half, which is called the first quartile. We found the interquartile range, which is the third quartile minus the first quartile. We got 5 there. We then determined the interquartile range multiplied by 1.5. So 5 is our interquartile range multiplied by 1.5. We got 7.5. From this, we can find where our lower outliers will be. So like what qualifies as a lower outlier. Anything below that first quartile, 14, minus the IQR times 1.5, which is 7.5 in this case, 6.5. Anything below 6.5 is a lower outlier. We don't have any lower outliers in this distribution here. Higher outliers will be the third quartile plus 1.5 times the IQR. So that's 1.5, I'm sorry, that's 7.5 plus that third quartile of 19, we get 26.5. So anything above 26.5 is a higher outlier. As I look here, I've got 38. Now, I messed up today in class a little bit. I mentioned that we need to create our box plot, and part of the box plot is the whiskers, right? So off to the left here, we go to our lowest value. Remember, we had no lower outliers. We go to our lowest value here of 8. So there is 8, my minimum value in this data set. And then the higher whisker, I mentioned in class, it's in this case 26.5, that limitation for higher outliers. That was incorrect. I sincerely apologize. I don't know why my brain went sideways like that. But what this whisker actually should go to is the highest value, the highest observation that is not an outlier. So in this case, it's 21. So instead of going up here to 26.5, should have actually gone to 21. So here is the correct box plot for this problem. Remember, the outlier, in this case 38, it needs to be marked with like an asterisk or a star or a circle, something like that. And if you recall also, in the event that we had multiple outliers at that one place, we wouldn't be able to know if there was one or more than one. So that's like one kind of like downfall, if you will, of a box plot. We don't know if there's multiple outliers at that one spot. In the event that we did have multiple outliers to the right of our higher outlier limitation here, we would need to have them all with stars here. So like if there's a 35, we would want to have a star here at 35. So just wanted to clarify that first thing. Let's take a look at this problem. The American Statistical Association has an Instagram account. Here are the number of Instagram likes for 10 of their posts selected at random, along with a dot plot. So 2, 4, 5, 6, 7, 8, 8, 9, 15, and 16. There you see the dot plot that accompanies that. Identify any outliers in the distribution, show your work. So we're going to use the IQR multiplied by 1.5 method to determine where those limitations are for the lower and higher outliers, and then if there are any higher or lower outliers in this distribution. First thing we're going to do is list out all our observations from least to greatest, and then we will find the median. Since we have 10 observations, 10 divided by 2 is 5. 10 is an even number, so it's going to be the mean of the 5th and 6th observation when listed least to greatest. And that median is 7.5. From here, notice that the median was the mean of these two values, 7 and 8 here. So our top half, our top 50% is 8, 8, 9, 15, and 16. So we're going to find the median of the top half. We do the same thing for the bottom half, 7, 6, 5, 4, and 2. So that looks like this. 9 is our third quartile, and 5 is our first quartile. Once we have the first and third quartile, we can find our interquartile range by subtracting. and we get an interquartile range of 4. Now we're going to find the IQR multiplied by 1.5, and we get 6. Once we've identified that, our lower outliers will be below the IQR subtracted from the first quartile. So the first quartile minus IQR, that's going to identify our lower outliers. So that looks like this. First quartile was 5 minus an IQR, 1.5 multiplied by the IQR of 6, which results in -1. So of course, we don't have any negative values in this. That does happen sometimes, by the way. We're only going to have positive observations, but the difference between the first quartile and the IQR ends up being negative. That you did not make a mistake. That does happen on occasion. There's no negative values in this. There are no lower outliers in this. If you want to see another example similar to this in your book on page 67, toward the bottom there, how many goals, identifying outliers, you'll see another example where we do get negative values here for the limitation for our lower outliers. So our higher outliers are going to be greater than the third quartile plus 1.5 times the IQR. So that's going to be 9 for our third quartile, plus that 1.5 times the IQR was 6. So anything above 15, the only observation above 15 is 16. So that is our only outlier there. So we're going to say 16 is above Q3 plus 1.5 times the IQR of 15, and therefore an outlier. And I should add some context here too. So 16 likes, let's slide that over there, 16 likes is above third quartile plus 1.5 times the IQR of 15 likes, and therefore an outlier. So when you're asked to show your work, we do need to kind of detail the lower outlier, the higher outlier, the IQR times 1.5. So let's make sure we provide detail for that, not just numbers, but what these numbers represent. All right, so as we look at this problem, we're going to compare distributions. Let's read it though. The American Statistical Association has an Instagram account. We just looked at those likes a moment ago. Bedford, Freeman, and Worth, the publisher of this textbook, also has an Instagram account. So we have both observations of the likes for those two Instagram accounts for 10 randomly selected posts from each account. We've created parallel, or we've been given parallel box plots and numerical summaries of the data. So from the numerical summaries, we can see the number of observations, 10 for each. We can see the mean, 8 for one, 17.8 for the other. Remember, the mean is sensitive to outliers. So if there are outliers, that is not a great measure of center. Standard deviation, there you see that. One distribution is more spread than the other, 8.08 compared to 4.472. That also is sensitive to outliers. So if we have outliers, not a great way to measure variability. We have our minimum value, we have our maximum value. Again, that we can find the range from that. Range is sensitive to outliers as well. We have our first quartile and our third quartile. We can find our IQR from that, and we have our median. So let's think about shape for a moment. Shape, if if we have a distribution with outliers, we end up with that long tail. So if we had a dot plot, for example, and we had some points here, and there were some outliers, like out here, maybe that, something like that, right? And we had a bunch of dots here and a bunch of dots here and here and here, but we had these outliers. These outliers will cause our data to be, or our distribution to be skewed, in this case to the right. Of course, if the outliers were to the left, it would be skewed to the left. So as I look at these two distributions, I see an outlier here and an outlier there. So that's going to let me know that both of these distributions are skewed to the left. I may have said left there, sorry. Both distributions are slightly skewed to the right, We're always going to be skewed to the direction of the outliers. If we have outliers only on one side, meaning that it's not a symmetrical distribution, right? So one outlier to the right, one outlier, at least one outlier to the right, and at least one outlier to the right. I guess we could see for sure because we've got the actual data set up above, the actual observations. So there's 38 there in the BFW group, and then 16 in the ASA group. So these are both slightly skewed to the right. So if we're going to be measuring center, we have outliers here, and with us having outliers, we want to look at the median. So let's look at the median of these two. BFW's median is higher than ASA's median, 17 compared to 7.5. So I wrote the BFW Instagram account had a higher median of 17 likes compared to 7.5 likes for the ASA account. All right, let's take a look at the outliers here. We have an outlier at 38 for the BFW account. We have an outlier of 16 for the ASA account. So I said both accounts have one higher outlier, BFW's post with 38 likes and ASA's post with 16 likes. For variability, we are comparing two distributions with outliers. So IQR is the measure of variability that is resistant to outliers. So we want to use our IQR here. As I look at my third quartile and first quartile, 9 minus 5, we have an IQR of 4 for the ASA Instagram account, and we have an IQR of 19 minus 14, 5 for the BFW account. So I said the IQR for likes on the BFW account 5 is greater than the IQR for likes on the ASA account, which is 4. There you go. All right, so let's make sure we use comparative language here. One is higher than the other. Let's make sure we're using context as well. What is this describing? It's describing the Instagram accounts for the American Statistical Association. ASA is fine. And for Bedford Freeman and Worth Publishing, which is BFW, that's fine too. So make sure you follow that criteria. Thanks for watching. Have a great day.